Welcome back. Let's do some more auxiliary views. We're going to draw this little bracket right here. Let's kind of go through what all the pieces are on this guy. So you've got this part here with the two holes in it. I'm going to call that the base, and it's 15 millimeters thick. And then this part right here with the hexagonal hole in it, I'm going to call that the flange, and that's also 15 millimeters thick. And the flange is inclined by 30 degrees to, let's call it the vertical. And the base has a notch, or is cut, let's say, at 45 degrees in the horizontal plane. Let's see, this flange is 50 millimeters wide and has the hexagonal hole is in the middle of it. 25 millimeters is the middle. It's 75 millimeters tall, and the hole is 50 millimeters up, and the base is 60 millimeters wide with two holes at 30 millimeters, and there's a hole 20 millimeters over and a hole another 40 millimeters from that. These little checks are surface marks. They just mean that those surfaces are machined, there's tables that you can look that stuff up if you ever really needed to. All right, these circles are counterbore, so that's what these dimensions up in here are trying to indicate, that there's a 10.3 diameter hole all the way through, and then a 20 millimeter counterbore, and they don't give you the thickness on the counterbore, so you just have to guess something. Typically in manufacturing, they just want a smooth surface for a bolt to rest against, so it's just counterbore, just enough to make it smooth, so that's why they don't put the dimension on there. All right, this hexagon is a certain size given by this up here, so 26 millimeters across flats, so that means from line to line, like this line right in here, and over to this other flat line. So basically the distance, the wrench size, the distance from flat surface to flat surface is 26. Okay, that's pretty much it. Now down in here they've kind of given you a little sketch on how to set up the views. So okay, I'm going to move these off to my secret hidden monitor, and what I'd like you to refer to is this drawing in the instructions. So let's go through this a little bit. So here is the front view, and here is the end view, and here is the top view. Now the front view is, well, you could also call that the side view. All right, then up here is the first auxiliary view, and here's the second auxiliary view. So the first auxiliary view you generate from rotating about a line here, and then the second auxiliary view you generate from rotating about a line this way, and you're going to project over to this perpendicular line to get the distances this way. All right, and to get the perpendicular distances, you need to go two views back. So that's what I'm trying to indicate with this A1, B1 business. And down in here you see A2, B2. So basically you have to generate this construction right in here, and then move that over to here, and that'll give you the distances this way. All right. Likewise, we're going to project over to this second auxiliary view, and that'll give us the distances this way. Now to get the distances this way, we need to go two views back and construct this little thing. So basically we're gonna construct this thing here and move it over here, and that'll give us the distances this way. That's the two views back trick. And then the distances this way we get from projecting these lines down there. Okay, the cool thing, there's lots of cool things, but one of the really cool things about this assignment is it forces you to use projection in the way that in the most valuable way, honestly, because the value of projection is to be able to solve problems where you know some information in one view, and then you know other information in another view. Okay, that's what it's really for. Is when you're doing design work and you don't know what the thing in the end is going to look like, so you're trying to determine what the final shape of the object is, and you do that by some values and distances in one view, and some distances in another view, and you have to combine that using projection. So that's why flat pieces of paper are good for this kind of thing, like as opposed to a 3D tool, which often for many problems 3D tools are great, but for there's other kinds of problems where they're not so great. So this projection technique is a very good technique to have in your toolkit, and this assignment sort of forces you to use projection. And what I mean by that is let's go back to for a second to this dimension drawing right here. So we know some stuff in the base view, like we know that it's 60 wide and 150 long and 45 degrees. We know that. So we can draw part of the top view because that information will show up in the top view. And but we don't know, how tall this flange is in the top view, because it's inclined. It's inclined twice. It's inclined 30 degrees and then rotated another 45 degrees. So to calculate that out, it would be pretty tricky. You might mess up if you could even visualize what it is you have to calculate. So what you do is you have to draw the view in which the lengths are true. This 75? The 75 is only true in this first auxiliary view. Well, it's true in this first auxiliary view, and it's also the true length in the second auxiliary view, right? And yeah, so the second auxiliary view, you're seeing the true shape of the flange. The 50 and the 75 apply there. And then in the first auxiliary view, you're seeing the 75 and the 15. Those apply there. But in the top view, none of those lengths of the flange are the true length. Well, actually, one is. This one is. The 50 here is the true length, but the others aren't true. And down in here, in the front view, I think none of these lengths in the of the flange with the hexagonal hole, none of those lengths are true length in this view. Okay, so this is good stuff. So look, what we have to do is we have to draw what we know from the dimension drawing in the appropriate view. Like we know some stuff in here, and we'll draw that, and then we know some stuff here, and we'll draw that, and then we'll project back and forth to finish up the rest. Okay, so once again, we're going to know some stuff here, some stuff here. I think we'll know some stuff here. We'll know some stuff here. So you draw what you can, and then you go back and forth as necessary to get the rest. All right? So here we go. AutoCAD. Boom. This is a metric drawing, so you need the metric template. A size millimeters. There he is. Let me get my unwieldy mouse under control. Okay. I bought a mouse with the scroll wheel's a little bit funky. Okay. Okay, I'm going to be referring to the dimensions that are given in the handout. In the top view, I know some stuff. I know that the top view is 60 millimeters wide. Right there. And I know it goes out this way, but I don't know exactly how long, so I'm just going to make it crazy long, or long enough. And then I also know that the top view has 115 millimeters along the bottom here. I know that much. Okay, and then I know that this line is at a 45-degree angle. That's what I know so far, and I'll fillet radius 0, and I'll trim this corner off. And that's kind of what I know. Here, I'm going to do a couple of stretches on this border here. I'm going to, so stretch, draw a line that crosses all of those guys, enter, turn on ortho, and pull him up, and then another S for stretch, and then cross these guys, enter, and pull that over there. I'm gonna need a little bit more room for that thing. Okay, that's what I know for that guy, and I need to move him already because I didn't have enough room in there. Let's move him right, right there. All right, then the front view, I know a little bit of stuff. I know, you know what, I want to make sure that I come lined up, so I'm just gonna start the line there and then go over that away and then offset 15 millimeters up, and then and then trim this guy. Different ways to do stuff. All right, let's see, what do I know now? I can use projection to finish off the part of the base, but not all of it, because I don't know really. This thing up here is not where the thing actually is, but I'm going to go ahead and draw that for now. But it's really, it's not there. It's here. I can draw a little bit more of this thing. Here, I can rotate this line about this point 90 degrees. Well, I want to copy. And then 90 degrees. I want that. I can offset, well, no, yes, I can offset the width of the flange by 50, because that is the true length, or a true distance. And I can trim off these guys, delete this thing. Okay, now I can come down to there and trim off these guys. Okay, that's correct. This is 50. That much is correct. Here I don't know this distance yet. And I can't draw really any of the flange in the front view yet, so I don't know any of that stuff yet. So let's do some projection to find this stuff. Let me move this stuff down a tiny bit more. All right, let's copy this line out here. Just enough space to fit in the first auxiliary view. So we have to start working on the first auxiliary view. Okay, then I'll start projecting from each one of these points perpendicular to this thing. And then I can construct the base, which I happen to know is 15 millimeters thick. So I can use an offset this 15 millimeters and trim it up. Okay, then I know that the in the auxiliary view, this flange is inclined 30 degrees in that view. So I'll rotate this line about this point. I'll rotate it minus 30. Oops, I need a copy. So once again, this guy I want to rotate about this point. Click copy. I want minus 30 degrees. Okay, that, and you can double check that. You can angle, you can click this line and this line. It should tell you 30. That's 30, true, in the auxiliary view. How do you know that? Well, you just have to visualize this thing in your mind's eye. Look at the isometric and kind of study that, and hopefully you'll be able to see that that's a true 30. So now we'll offset that by 15 because we're kind of looking, straight down on these two lines represent a surface. This line and this line, they represent a surface that is in the plane of the paper. So that's going to be a true surface, of a true shaped surface of the flange with the hexagonal hole in it. All right, so we'll finish up that guy. So from here to here is perpendicular. I'm really just trying to get the length of this thing, so we can here it might make more sense. It might make more sense if I did it another way. Look, if I take this guy and move it back to there, all right, and then change the length to 30 or to 75, and use the length command and then tab and then 75. That line right there, 75, because like I was saying, these two lines represent the flange, the edge of the flange in its true shape. So I can finish that off now. Basically, this little rectangle that I just drew, let me clean him up. That's these four guys, that's the flange. It's 15 millimeters thick and 75 millimeters long. True. Okay, now I can project back from the first auxiliary and finish up the top view, all right? So this might be a mistake, that line right there. Yeah, that's a mistake. Let me get rid of that. Why is that there? This one's okay, but the other one was a mistake. We wanna project back now. So I need a line to project to. So I'm gonna grab this guy right here and copy him. I'm just picking a point out in space, and then down in here, I just want a line at the same angle. Okay, and then click him and lengthen him. That's longer than I need, but okay, now I can do these projections. From this point, I'm going to project perpendicular to that, and from this point, I'm going to project perpendicular to that. Now I can finish up what the flange looks like in the top view. And that's what it looks like. Let's trim off these guys. Okay, so this right here is what the flange looks like in the top view. And let's see, this dimension is true, it's 50, but this dimension is not. It's not in the plane of the paper, so it's some weird length, all right? It's only got the true length back in this other view, all right? Now I can continue like this, and I can project down from this guy to locate the, or to determine what the flange looks like in the front view. Okay, I brought the four corners of this. Let's see, the four corners of the top of the flange. I brought those down. Now I need their heights. I can get that from two views back. From this view over here, I can get their heights. So let's offset by 20. No, sorry, offset 20. Arbitrary 20. I just need a parallel line to this so that I can project over. Follow the process that I'm doing. It's a little bit hard to articulate, but do what I'm doing here. Okay, so I'll trim this off. So basically, these four lines that I drew represent, they represent straight up and down in the front view. they represent distances this way in the front view. So if I grab these four guys, and I'll grab this guy with him just so I have a reference, and I'll copy them from this point to this point, and then spin them around. Rotate these dudes about this point, click reference. Center is here. First reference angle is here, and then I want to go straight up. So I could use this one there. Then, you know what? I'm just going to stretch these out with press F8 ortho. You can do that. Click the point and just drag it. You know, click or not click it, and then move your mouse, and then click again. That's the two tops. These two lines here, distance from this line gives me how high the flange is, and then these four projection lines give me two more locations, and so we can connect the dots. I'm going to heavy now because I've got something that's sort of an answer. All right, so we'll start heavying in over here on what we can all agree on is supposed to be there. That stuff's there, right? And there we go. That stuff's there. Yeah, everybody agree with that? Oh, and there's two lines super close together. The rightmost one is this one. Okay, and the left one is the top of the flange in here. So so let's find a line. So see, the flange starts here and it goes kind of up that way, right? Up to what? Let's see, this is, if it's the front of the flange, it's going to be taller. So it's got to be that one, right? Then it's got to go to that. Then it's going to come to here. And then it's going to come down there. I guess and check, kind of use my mind's eye, sort of. And I'm checking the angles now. The angle's 292, and this one's... if I drew it the other direction, if I added 180, I would know what it is. But you know what? I don't feel like doing addition, so I'm going to draw it backwards. And then check the angle. 291, and this one, 292. Close enough. There's a little bit of rounding error in there. Okay, then, look, I got a line coming down from this point somewhere. I don't really know where it is, but I know it's parallel to that guy, so I'm just going to copy... In fact, I'm going to copy this one, and this one. Copy. From, look at this trick, from here to here. How about that? That's neat, huh? Play that again if you need to. And then we'll draw a line from this point to that point. And this one, some of these are hidden. This one, and this one are hidden. Make them cyan. I think I need to change my line type scale. LTS for, whoops. LTS for line type scale. I think 10 would work, right? Yeah. Maybe 20. Yeah, 20. Okay, and then trim off these guys. Because they, yeah, there's a funny angle on the bottom of this flange. Assuming they welded this thing together, they had to grind this flange down to have the right angle on there. Okay, that's that. So you see how we did that? We had to do some of it in the front view, and then some of it in the top view, and then some of it in the auxiliary view. Okay, let's throw the holes in there. So I'm going to do a couple of offsets. 20 millimeters over from this guy, there's a hole, and then another 40, there's another hole, and then I think it was 30, right, in the center line of this thing. So there's couple of circles there. So let's, there's a circle here, and it's got a diameter of 20, I think, right, 20 millimeters, And then there's another one here, same 20 millimeters. And then, whoops. Then there's the hole that goes through, and that has a diameter of 10.3, which is an odd. That's a very strange. It's a very strange diameter. Those guys, those show up as hidden lines in the front view. So let's go ahead and do that. So I can come down from this point and go perp and come down from this point. So I don't have to think about the numbers so much. That's the other value of the projection, is you can think a little more spatially instead of with the numbers. So there's a counterbore. They don't give me the depth. I'm just going to guess, or let's say it's 5 millimeters. I'm just going to decide that it's 5 millimeters. And we'll trim this up. Cut that off, 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 that, and delete the junk. It's a counterbore right here. This thing here should be cyan hidden. Okay, and you know what? We'll throw a little center line on there. Make him blue. And center line. Well, I could mess with the line type scale a little bit, probably, or I could stretch him and see if he behaves. There he goes. Stretch him out a little bit and he gets a little more center line looking. So look, there's one here, and I could copy this from the center of this to the center of that. Just use the circles for your 2 points on the copy. And I can do better than that. I can grab both of these guys and copy and pick, let's see, pick, which one should I pick? Maybe this one, and I think I can drop him here. Yeah. Then I could do some fancy rotations. I could do rotate this point and then reference. So center point, I think I want perp to that, and then, did I get it? No. I was too ambitious. Neither one is anywhere close to there. So I need some more projection lines. So that perp, and then another projection line from the center of this perp. Yeah, they're not the same distance apart because this line and this line are not in the plane of the paper. So these two holes are not the same distance apart. You have to come off of this view over here. So I'll just move these guys now. So try and grab those things and move them from this intersection to this intersection. That's where they should be, or that one, and then this guy, move him from this intersection to this intersection, and then I can delete my projection lines that I used to locate those guys. All right. I can heavy in a little bit more. All right, let's heavy in some of the top view here. Okay, we've got to get in. Oh, I messed up. Okay, my snap is fighting me. I'll turn off grid snap right there. And this thing. Yeah, that's better. And then there's a line from here to here. So the more observant among you would notice that there's something wrong in the isometric. Okay, if you study kind of what's going on in this corner in here, you'll see that there's something not quite right in the isometric. I've corrected it or adjusted for it by drawing it this way. So just do that. This guy here, I could draw a line There we go. That's the top view, what I know so far, and the front view, what I know so far. And I drew them by going back and forth between all three views. All right, I can do some more heavy. There you go. That's what that looks like. All right, let's finish up the hex and then we're done. Okay, to get the hex, I need to rotate about this point here to get the true shape of the flange with the hexagonal hole. So I'll copy this guy from some point just to another point about there, and then I'll stretch him out with lengthen in both directions a little bit. Okay, so this is just a line that I can project to. It represents rotating about this line in here. So I'll just start projecting from all of these points perpendicular to that. Let's go ahead and trim. No, let's go ahead and just finish up the hexagon real quick before too much more happens. So I'm gonna, that's the width of that guy, and then 0.25 is the center line of that guy. Whoops, offset 25. I think I did a 0.25. Wait a minute, that's bad. Oh yeah, there he is. I did 0.25. That's not good. Make sure I'm deleting the right one. Yeah. All right. Then offset 25. That's the midpoint of that thing. And those really should be construction lines. I'm going to go ahead and let's flip back to construction real quick. Okay, and then back once more time for the new stuff. All right, that's that. Let's put a hexagon in there, which I know is 50 millimeters up from this guy. And I know that the distance across the flats is 26, so half of which is 13. So I'll go up that way and over that way, and then grab these two guys and do an array polar about this point. And default is 6, but 3 will do. Okay, then go back into heavy. I need to write a macro to switch these two line type settings. If anybody knows how to do that, let me know. I just want one button that I can punch and it'll flip both of those from construction to heavy red. Okay, that's that. And I also, well, I got this thing on red. I'm going to heavy in stuff I know is done. That's done. That stuff right there. That's the flange. I'm going to go ahead and delete the array, the polar array that I did. Okay, that's the flange, the true shape. Let's go ahead and go back and finish up the hexagon in the other three views. All right, so I'll go back to construction. Okay, I'm going to project back perpendicular those 2 points. Okay, I can draw the hex, which is really just a couple of hidden lines. Let's go to heavy. Yeah, this is a pain. And draw these 2 lines real quick, just so that we've marked those guys, so we know they're done. That's done. All right, that's what the hexagon looks like as hidden lines. If you wanted, you could do this. You could draw perp. Really, I want a center line. That's nice, just to make it a little more clear. That's what that looks like. That's what the hex looks like in the first auxiliary view. This is the first auxiliary view up here. This is the second auxiliary view. Let's see what the hex looks like in the top view. So we're gonna go back to construction, projection, flip all of these guys. Oh, I could set up another layer, you know, and then I could just change the layer, but I don't really like layers that much. For managing the layers is kind of a hassle sometimes. Anyway, let's just project from the there's something weird going on in here. Whoa, this guy. I gotta redo these projection. All of this stuff's messed up now. Shoot. Maybe I can fix it. It might not be too bad. I don't like that. I'm gonna redo these. Something down here might be messed up a tiny bit, but I'm just gonna, oh wow, what's going on? No, there's worse than it's even worse than that. Which one of these is off? That one is off. This one, they should have an angle 0. Oh God. I hope that didn't screw up anything too much. I'm just gonna press on. If this were a rocket taking people to the moon or something, I would redo it. But what are we doing? Oh, okay. So I got to project from look, from just the front face of this thing. Let's draw the hexagon on the front face which is in here, right? For the flange on the top view. So line from here to perpendicular to that, and then another one from here to perpendicular to that. Okay, so the hexagon is in between here. So I need to know how wide it is. I could grab this. I could bring the center line over too as well, right there. So I know the top is there, the center is there, and the bottom is there. But I need to know how wide, and I can get those from 2 views back, right? Right. I need to know how wide the hexagon is. I can get that from over here in this thing. All right. So let's do that. So I'll draw a line from here perpendicular to that, and another one from here perpendicular to that, and another one. These guys. Draw these guys. That gives me the width. Okay, so I can grab these, do a copy about, let's pick a good point, like maybe this one, and drop it on the midpoint would be good. Let's hold down Shift and right click and then do the midpoint snap override and drop these guys right there. Then do a rotate. Rotate about, Shift, right click, midpoint of here. Click reference. Okay, the center is, yeah, that'll do. And then there's going to be a point there, and then a point there. Okay, if you didn't like that, there's other ways by checking angles and then rotating them to the angle that you read numerically. You know, different ways. Do what you need to do if that just freaked you out too bad. So let's just extend these guys perp to that. Okay, I'm just using the lengthen command and dragging these guys out, perpendicular snap to those, to down around in there, and then this guy, lengthen and perp. This guy, lengthen, perp. All right, I got a grid, right? I got a grid, these 4 lines, which I brought over from 2 views back. And then I got these 3 lines, which I brought from 1 view back, and their intersections represent a hex, which I can heavy in now. So, where is it? Oh, it's somewhere. It's what? There, you think? Yes. To there? It's not straight down. It's at a slight angle. It's totally coincidental that it's even close to being vertical. Don't think that it needs to be vertical. There's several inclinations going on that guy. And then this one goes to here. And this one, once again, just happens to be close to vertical. That's it. That's the hex. That's what it looks like. Okay, there's one in the back. And we can do our little trick again. Watch, we can do this copy and these 2 points, right? So we'll copy from here to here. When the copy command asks you for points, choose a point, you know, there, right? And then another point, you know, there, right? 2 points on this top of the flange. And those are all hidden. This one's extra and get rid of that guy. And then there's a couple of hidden lines in here. It is messed up. No, it isn't. It looks messed up, but I think it's okay. I think it's okay. Actually, I'm not sure. I'm not super confident about what's going on in here. I think it seems like they should. I don't know if those should intersect or not. So I'm gonna leave it. I might have an error from that weirdness that was going on in here, or it might be just a coincidence that these guys are so close. And I don't really want to think about it too much right now. And I suggest you don't worry about it either. Just get it done. That's that. That's what that looks like. Okay. There's too much happening here. Let me clean up some of this stuff because there's just too much. Let's clean up. I want to grab, let's leave maybe the center line. Let's leave this center line and delete the other projection lines because there's just too much. And I think I'll delete all 4 of these guys right now because that's, once again, it's just too dang much here in this thing. I'm going to delete that as well. And I think I'm just going to leave, I'm going to leave this guy. You know what? I'm gonna get rid of that guy as well. And I'm gonna get rid of this and this. And that's solid, right? Yeah, and that's solid. Yes. There's a hidden line in here I could draw. I could project up from. See, it's gonna be this point, I think. Yeah. Not sure about that. No, I could grab it from over here, I think. I could get it from, maybe it's this one. Yeah. Yeah, that's right. And we could trim this, get rid of the garbage. This guy's hidden, right? Vote now if you think this is hidden. It looks fat, but it should be. It should be this distance. That's okay. Yeah, that's all right. All right, let's bring this hex down into the front view, right? So I'm gonna go back to fine hidden, or sorry, fine solid construction lines. Okay, we're gonna bring points on this hexagon down perpendicular. Make sure you get perpendicular snap, which I did not get just then. just bringing the front of the hexagon down, and I'll copy that as when I'm done with that. Okay, that's 6 lines. That's 6 points on the hexagon. These 6 lines right here. It's 6 points on the hexagon. Now I need intersecting lines that tell me their height. And I can get that from where? 2 views back, right? So this is the front view. I go 2 views back. So basically no. I need a couple more projection lines. I need to come off to this, because I want this line right here it would be vertical in the front view. Do you see? If you don't see that, then imagine rotating these guys around in space so that when you look down on them, they look like this. And keep track of where those lines are, and you'll see that this line right here would be vertical in this view. So we want to project, over to this guy. So that's what I'm doing here. So we'll grab this guy perpendicular, and we'll go ahead and grab this center point and perpendicular. All right, so this line, there's the base, there's the top of the hex, the center of the hex. Let's copy that set of lines from here to the end point of this, and then we'll turn it around so that it points up. It's the bottom, the top, and then the 3 lines on the hex. We'll do a rotate. About this point. Reference, center point, and then use F8 ortho to just pull this guy straight up. Then we just need the top and the bottom of the hex, so I'll just grab these points, and with ortho on, I'll drag them out that way. Just click them and move them using ortho. All right, so this is the top of the hex, this is the bottom of the hex. These 3 lines are the other points on the hex. Somewhere in this square is a hex. So we'll go to red heavy, because I'm confident that I can find these lines. So what? So the top of the hex is somewhere, there's 2 points somewhere along on this line right here. That's the top of the hex, right? And look, this point, this line, and that line come down from the top of the hex, and this line is on the top of the hex. So the intersection of those is the top of the hex. Down in here, the intersection of that right there to it's the rightmost line coming down here straight that way. That's the top. And the middle is this other one. And then back to the bottom. This line here coming down is right there. It comes out of the bottom. And then the other bottom is on the leftmost of these 2 that are close together. It's that one. And it's the rightmost one here, right? Then back to, make sure you grab the right one, because there's a lot going on in there. Make sure you're using the right snaps, endpoint, or intersection, or something, that whatever is appropriate. There's my hex on the visible surface. I can copy it, and I'll use these 2 points again. I'll use this point and this point, and now these 6 lines should be hidden. That's the hex on the back surface. Make that cyan and hidden. All right, and then there's a couple more hidden lines connecting the endpoint of that with the endpoint of that, and then another line from there to where'd he go? to there. This guy and this guy are hidden and cyan. That's it. Oh, there's a couple more, right? There's one here to here, and there's another one here to here. And those are also hidden inside. And is that it? Oh, and there's a visible one in here. There's a visible one when you can kind of look in the. Oh yeah. So some of these are visible, and actually it's even more complicated than that. Yeah. Because you can see into the hole a little bit. So let me make the stuff that's cyan that's right now. Okay, this one is actually solid because you know, you can see that guy. And then there's a little piece of solidness going on here. And likewise, there's another piece of solidness before you get to the edge of the hole right there. Technically, if you really wanted it to be right, then that's what it looks like. Okay, I'm gonna delete these because I want it to be pretty. That's what it looks like. All right, the last thing we have to do, and we'll be done, is this flange, or rather this base, the thing with the two holes in it. What does that look like in the second auxiliary view? What is that? It's going to be all in here. And what does that look like? Okay. Well, what we need to do is projection. I need a line to project to. I'm going to put him about here. I'm just copying one of these because I need a line at the same angle. And the reason is because I'm generating the secondary auxiliary view by rotating about this line up in here. So I need a line that is perpendicular, is parallel to that. I need a line to project to that's parallel to my rotation line. Right? I'm rotating about this line, so I need a parallel line down in here. That's what I did to generate the flange, but you know, I can delete those lines now because they're kind of, don't need them anymore. And let's just continue the projection that we were doing before, basically. Right? We could project all of these points down to there. So we'll grab this one. Yeah. Sorry, let's go back to hairline. Just grab everything. This one. The one back here. His buddy, this next guy, that one. And there's a couple of points in here. Look, here, right? The ones that come from this corner right in here, right? But that comes all the way through back. You know what? That's a hidden line. Right in here, there should be a hidden line. That's the back edge. I'm gonna go ahead and draw that because I just want to point out that that's what's going on there. Okay, there's a hidden line in the back edge of that, which now we need to project from over yeah. So we want to project from this perp and then another line here from there, perp. Okay, so this, we need another one. We need this corner, perp. So these two lines are back in through there, and these two lines are the far back corners, and these two lines are the far. So that's the easiest one to do maybe, is these four lines right here. That's the four back corners, right? the 4 back corners of this base are on those 4 lines somewhere, and so we need dimensions in this direction, which we get from 2 views back. So we need to project, and the way it works out without doing advanced geometric proofs is that we gotta project out to this dude. So we're gonna draw a line from all of these points out to this perpendicular line right here. You know what? I don't need all of these. All I need is 3 of these, I think. Yeah, let's grab the circles too. Do we want to do the circles? You know what? I'm going to leave that for you guys, extra credit if you want to do that. So I want to trim these guys up. Those are the distances I need right there. Is this and this and this. And I'll grab this along just to keep everybody together. So copy from where now? It's going to be this side or this side, one of them sides. Let's grab this side here because that's the back. That's like this part of the flange, and we'll put him here, and then we'll rotate these guys to the proper orientation. So grab them and then rotate. This is the rotation center, and then reference. And to specify the rotation angle, we want the center again, and then this point, and then we want to pull these guys up this way. That does not look right. Okay, it's okay. I just need to move these. I'm going to move them from here to here. That's what I want. And I can just, I'm going to delete this projection line because it's just, that's right. Right? This line lines up with this. That's this line lining up with that. Okay, so we should be able to draw this. Well, I need to extend these guys. Lengthen these guys with perpendicular snap. And I'm going to trim up. I'm going to trim these guys off just so that it looks nice. Okay, somewhere in this grid is the flange we're trying to draw. So I think the easiest thing to do is find where these two edges, this edge and where's the other hidden edge? This guy, right? Those two edges, where are those on this second auxiliary view down in here? Where are they? And there's one, this line here corresponds to this line, and these two lines are the matching one. So the intersection of these two lines and this line, there should be a line right in here, right there. Make him red. I had to draw him before I forgot where he was. There he is. Likewise, these two lines match up to this one, which goes over to this guy, which goes over to that guy. So basically this guy lines up with, or matches this guy, and they go through these guys. So in here there's a line. So right here there's a line. There it is, and the rest should be kind of easy. Let me go heavy red first. So red. Okay, just connect the dots now. So this one, One more time. I forgot what is the heavy going on. There's no. Okay, I got my heavy going on. This one to this one. This one to this one. Yes. Some of those might be hidden, but where do I go? Somewhere over here, right? Like, what do you think? If I extended this perp to that, then I think I could squeeze this. I think there's a guy right there, right? And then there's a guy. There's a line right there, I think. And then I could. So, you know, once again, now I know there's a line going off this way, but I don't know exactly where it goes. It might go there, but you could grab these two and copy these from this point to this point. Yeah, and then you could just extend them. Yeah, and if you, as a double check, you should be able to go from these points. Something's. It might still be okay, you know. Let me do one from here to perp to that. You know, I think it might still be okay. I think there's a, you know what? There's a line. There's a line somewhere in, right? Somewhere in here, there's a line. It's over here, right? If this point, that should show up as an edge over in this view. If I come over here, perp, yeah. So let me draw another line on top of that. Okay, and then I can just delete all of that. This is an edge. In fact, that's not, this one here is actually, shouldn't be there. Technically, it should stop there because kind of all in here is one surface, really. Trust me. Now I can sort of check some of these and maybe they'll line up. Yeah, look at that. That one lines up. And then that lines up. Hey, sweet. All right. I think I'm done. And, you know, the other thing to do is find these two holes right here. Locate those guys in the second auxiliary view. And what you do is you'd draw a parallelograms. You'd bring over these quadrants and project them all through and establish some parallelograms. And then inside those parallelograms, you're gonna draw an ellipse. So that's extra credit if you feel like messing with them. I think I'm done. Yeah, the only other thing to do maybe is kind of clean the border up. Here, I could delete this line right here, and I could, you know what, I could just grab all of this stuff right here and move it with grid snap on and perp and ortho on and put him right there, and then I could do a stretch and one more time, stretch this stuff. Enter point, zoom extents. Yeah, capture that, stick it in your document. All right. That was kind of a workout. I'm tired. All right, I hope that was helpful to you. Have fun. This is good. It took me an hour. Could take you more. Could probably take you 3, something like that. All right. Have fun. See you next time.